Start video. Okay, so maybe I can edit this. So this is 4.4, which is exponential, and it's a logarithmic equations, y'all. So I did P2, it was part 2. Okay, so what we did last time was we had equations and they were written in like an exponential form type of way, right? And the way that we're going to solve those is we use log. If it was written with the base of e, we use the natural log. If it was written with, say like 10 was our base, we use the common log, right? Like when we were able to solve those. And like what you do is you're solving for x. So we're going to do the same thing now. We had done the first part was exponential, and now we're going to look at our log equations, okay? So I've got 2 methods also for here. I've got a method 1 for our log equations, and the actual steps that we're going to follow, y'all, is to condense to 1 log. And honestly, that's going to be your clue that, hey, this is what I need to do, right? Because you'll see multiple logs in your problem. Well, I need to condense it into 1. So condense to 1 log, change forms. Well, if it's written in a logarithmic form, what I mean by change forms is to go to exponential form, right? Comma, solve. And then, okay, so this is kind of like as needed. So what I did was just like put it in little, like, I don't know, less than, greater than thingies, kind of like parentheses. I put reject as needed. It'll make more sense when we do a problem that needs to be rejected. Mainly if you solve for your x and you realize x equals -1 and 2, we can't take the log of a negative number. So like you would reject -1 as an answer. The answer would just be 2. That's what I mean by like you reject if needed. And then like I said, because these are logarithmic problems, the way we're going to change form is to go into exponential form. So let's go and do this first problem. What I have here is log base 11 plus log base 11 of, so in parentheses, I have 10x minus 1, close your parentheses, set it equal to 1. So I've got multiple logs going on, right? So I know that I need to condense it to 1 log. Condensing means using the properties of logs. So because this is addition, what I would do is these would be adding each other. Oh, sorry, y'all. There's an X there. When I looked at my problem, I was like, hold on, something's not right. There is something there. I do apologize. It's log base 11 of x, and then plus log base 11 of 10x minus 1, and then that left-hand side is equal to 1. Okay, so now, sorry, because these 2 logs are adding to each other, what you do is you actually take, these would be our a's, right, in logarithmic form. You're going to take them and you're going to multiply them, keeping your log of the base that you have, which would be log base 11. And then it said we could multiply both of these because they're being added. I could do x and then open 10x minus 1 equals 1. I haven't done anything to that right-hand side. So that's using the product rule, right? It's actually kind of going into them being a product of each other. Okay, and so now what you would do is just distribute that x into that parenthesis. Log base 11, 10x times x would be 10x squared, and then x times 1 is x. Signs are different, so it's negative. And then we have equal 1. And so now I notice I've condensed it, right? I've condensed it completely. I don't have any operations. Yes. Condensing. I applied the property of the product rule. Because they were adding to each other, I can make it a multiplication problem and drop that operation of addition, and it gets rid of one of the logs because I'm combining it together. Like I'm making it smaller. Okay, and so now you'll notice that right here, I've got a log problem. The only way I know how to solve log problems is by changing its form. So now I'm at the point, I've got one log, change its form. So what I mean by changing its form is going into b of x equal a, right? So this would be 11 to the first power equals this. So I have 11 to the first power equals 10x squared negative x. That's literally just going to b to the x power equals a form. It's going to ask you to write the equation not in logarithmic form in your homework. This is the first answer that you input. Is it actually written in an exponential form, right? When you change the forms, and I literally, when I did it, like I raised the 11 to the first power and everything, and that was the correct answer. Now we're going to actually solve it. That's just like, hey, show me you know how to change from logarithmic to exponential. Okay, and so the way I would solve this, solving means I need to know my value of my x, right? So I noticed that if I move this 11 to the right-hand side, what I'll have is a trinomial, and I can use a method that I learned to actually solve for x. So moving that 11, right? 11 to the first power, y'all, is just 11, right? Okay. So if I move it, what I get is 10x squared negative x negative 11. And then here, even personally, I couldn't just trial and error it because I wasn't too sure with this leading coefficient being 10. So what I did was I came over to the side and I did the AC method. My A is 10, my C is 11, and it's a negative 11. So 10 times a negative 11 equals a negative 110, right? AC method, wouldn't I factor this? Right? You can actually start dividing this. You'd get 1 and 110, you'd get 2 and 55, you'd get 4, whatever, right? I looked at my B and I noticed that B means that whenever I combine these two things together, one's negative, one's positive, that they have a difference of -1. I'm going to get that by doing 10 times 11, my 11 being negative. Or you can just have them all listed. And you'll see if one of these is negative, how do I get to a -1, right? This is going to be your combination. So these are my new factors that now I rewrite this trinomial, expanding my B term with these right here. So I get 10x squared, that's a positive 10, don't forget your variable, negative x, don't forget your variable, and then negative 11. Now we have a factor by grouping problem. You split down the middle, pull GCFs. The greatest common factor between these two terms would be a 10x. When you divide, you get x plus 1, close. Bring down your negative sign. Then the greatest common factor between these terms would be 11. Whenever you do your division, you get x plus 1, close. So this tells me that in factored form, this trinomial is 10x minus 11 times x plus 1. You see what I'm saying? I wasn't going to guess that by just using trial and error, not easily at least. And then there's a lot of trial and there's a lot of error. So I just came over to the side and did AC method. Now that I have this, what I would do is set each factor equal to 0, right? And I solve to see what my x values are. Right here, I would get that x equals 11 over 10. Or I have that x equals, what is that? That would be a -1. But what do we know? We know that we can't use negative values here. Like we can't take the log of a negative number. So that value, right, that's rejected. That's what I meant by reject as needed. That value's been rejected. And so what you have for your answer is that your x equals 11 over 10. So you see how it kind of is like all inclusive of a lot of the things we've done in class, right? Okay, so let's do the second problem. Say we have log base 4 of, in parentheses, it says x plus 11, close. And we're going to subtract from that log base 4. In parentheses, we have x minus 4. That's so annoying. And then we have it set equal to 2. So if I've got two different logs and one subtracting from the other one, What does this end up getting turned into whenever I condense it? Is it a multiplication problem or a division problem? It's a division problem, and it's because of that subtraction sign right there. That's me using that property of logs, which I believe was 4.3. So you keep your log and the base that you're in. These two values right here, what you do is when you subtract them, you actually can write it as a division problem. And you put them over each other. We have that equal to 2. Okay, so once you have this, I've done the condensing, right? I went from multiple logs to one log. The next step said to actually change the forms, go into exponential form. Exponential form is b to the x equals a. So here's my b, here's my x, here's my a. So b to the x equals a. In your homework, when they ask you to rewrite the logarithmic form without using logs, I mean, it's like they're basically telling you change the form, right? How are you solving this problem? Once you change it to exponential form, what do you have? This is what you have here, okay? And then now what you would do is you just start evaluating it. I know that 4 squared is 16 equals x plus 11 over x plus 4. I know that I have a binomial, right? Those two terms, x plus 4 in the denominator, in order to solve for just x, like I can't have it in that form. So what you would do is the inverse of division, which is multiplication. I would multiply both sides by x plus 4. So I would have 16 times x plus 4 equals, if I multiply this right-hand side by x plus 4, your x plus 4s cancel. Like that's why you're doing it, right? The inverse should get rid of what you're trying to get rid of. So, oh, that's just a typo. Oh, anybody got white out? No? Do you really? Ooh, bring it. Please and thank you. That was literally just typo. So here, okay, so x minus 4, x minus 4, x minus 4, and right here will be x minus 4. So all those plus 4s are minus 4s. Thank you so much. Leah, right? I win. And I like replay everything in my head, just like my whole life. My husband thinks I'm crazy. And it would probably be like tonight, going to sleep. You know what I mean? I would remember it, and I would just be like, I'm never returning to class, ever. He'll always remember me like that. And look, I was even smart. Instead of doing it and trying to write over it, look it. Okay, I got it right here if you need it. Okay, so x minus 4 is the denominator. I accidentally wrote x plus 4. I know I needed to get it out of the denominator, so I multiplied both sides by the denominator. So x minus 4 times the left-hand side. And then if you were to actually multiply this by your denominator, they end up canceling, which is what you wanted anyways. The only thing that remains is your numerator, which is x plus 11. And then we notice that we have distribution on the left-hand side. Let's go ahead and distribute that 16 in. You would get 16x, and then you get a negative 64 equals x plus 11. And so now solving this, I would move my x to the left-hand side, and I get 15x negative 64 equals 11. Here I would add 64 to both sides, right? Yes, Alex. Move this over. So this is a positive, okay. And then if you move your negative 64 over, it becomes a positive 64. So what you get is 15x equals 75. Divide both sides by 15, you get x equals 5. That would be your value. There I just had one value. You notice if when you're working, like once you've already condensed it, you start solving it, if you have an x squared, you're gonna have two values, right? So I think usually end up rejecting one, if not both, because you know that you can't have something that makes it a negative number, because you can't take the log of a negative number in like your original problem. Here I had just x to the first power. So if you notice, I just get a single value for x, and that is the value for x. That's what makes that equation true. Okay. So now let's do method 2. I have 3 problems for this one just because I wanted y'all to just see it. If we can't get to the third one, I could do a video on it, but technically both values that you find end up being rejected and it has like no solution. But if we can do that, we will. And then we'll do the quiz. Okay, so for method 2. Okay, so what we want to do, sometimes I word things weird. Get equation to B. Get equation to B. Yeah, I just have get to, and then what I'm trying to get to, but I don't know if that's going to be ambiguous. Get equation to B, and this is what I mean. It needs to look like this. Okay, it needs to look like log of M equals log of N. Okay, that right there is implying that the bases are the same, right? If this said log of A and that said log of B, that would tell me, oh, they need to be different, right? There's nothing written there, so it's implying that my bases are the same. So whatever you have, you need to have your logs match. Once they do, it's similar to what we had done in the first part of 4.4, where when you get to this, you just do M equals N. This is actually, I think, one of the easier methods. This might not make sense, but when we do the example, it should make sense. So technically, you get rid of your logs and you just have your M equals N, and then you would solve it.
Wait, is it log base 10 or is it log base?
For this particular one, it would be log base 10.
Okay.
Because there's nothing showing. But as far as it's just being like a formula to follow, because it doesn't explicitly state that they're different, it's implying that you have the same type of logs on each side, whether it be natural log or common log, they're the same. And then once they are the same, and it's also saying that if you have a base of 2, this side, I can't talk, should have a base of 2. You have a log base 7, over here should say log base 7. Like it means that they're the same because it's not showing you that they're different. And then what you do is you get rid of your logs and you just have M equals N. Okay. So let's do this first example. What we have is log base 3 of, and in parentheses, I have x plus 2 equals, and then the coefficient 3 log base 3 of 4. So do you see how right now it pretty much looks like it's almost in that form, right? The only thing that keeps this problem from being in the form we need it to be in is that coefficient, right? But I have that property that I learned that said a coefficient can be made an exponent, right? That's going into condensing it. And if we were expanding it, that exponent would be a coefficient. So it's just a matter of like changing forms and moving back and forth. So what I want to do is go ahead and make that coefficient an exponent. And then now let me look at it again. Over here, I don't really have anything, so I'm not changing it. I just have log base 3 of x plus 2 equals, this becomes an exponent right here. I get log base 3 of 4 cubed. Kind of getting a little cluttered there since I'm using marker, but that's what I have right there. Okay, and so now looking at this, do you agree both sides only have one log, right? That's very important. That, I mean, if it needed to be condensed, it was, but both sides only have one log. They both have the same base. And then this would be acting as my M. This would be acting as my N. All we have to do now is just set M equal to N, which is x plus 2 equals, what is that, 4 cubed? Does that make sense?
Yep.
Okay. I'm looking at this problem wondering another way that it might show it. I think I kind of just said it though. Like if there's multiple logs, you want to condense it first to make sure that they both match. If you see a property here or there that you can apply, you want to make sure you do that as well. I think maybe more than anything, they might just have you condense. Okay, so now we solve this, y'all. X plus 2 is x plus 2. Right-hand side, 4 times 4 is 16. 16 times 4 is 64, right? Move your 2. What do I get? X equals 62. So that was a fairly easy example as far as like how to do that method. Okay. We're going to do these other two. Honestly, I don't think you'll need 10 minutes to do your quiz, so we should be okay. Oh, I already had paper. Overachiever. Okay, let's do the second example. Okay, so for this problem, we have natural log of x plus 2, close, and then we have minus, right? Subtract from that natural log of 4x plus 3, close it, and then set it equal to the natural log of 1 over x. So there's a whole bunch of stuff going on here, right? The goal was to set both sides of the equation need to have the same type of log, and then you just take the m and the n and you set it equal, right? So I notice on the left-hand side, I've got natural logs. Right-hand sides, I have a natural log, but I only need one on each side. So that's what tells me that I need to condense here, right? And the way you condense, because these are both natural logs, it works. I can do it. And because this is a subtraction problem, I'm actually going to take this as a numerator, this as a denominator. So you keep the log that you have. This is technically considered your m over and then n. But once you change its form, this whole fraction now is just m. And then equal. Okay, so the natural log of 1 over x, there's not anything else going on over there for me to condense, so I'm just writing natural log of 1 over x. So when it said to get the equation to look like, the only directions I didn't really necessarily write was if you need to condense, condense, right? Now it looks like what I'd written on the previous page, which was I have a natural log on both sides. This would be acting as my m, and this would be acting as my n. So just write your m equal to your n. X plus 2 over 4x plus 3 equals 1 over x. And I could do that because in front of them, they were both a natural log, okay? And then y'all, what you do here is you just solve. Because it's a fraction equal to a fraction, you would do cross multiplication, right? And so what we would get is x times x plus 2 equals 4x plus 3. And then now this is just a little equation. Do the distribution, move things around, combine like terms. You solve for your x in whatever way we see that we need to use. Here, I would get x squared plus 2x equals 4x plus 3. Because I see an x squared, that tells me that I'm going to be using one of those previous methods. I think that in the homework, I think 1 or 2 problems, they had you do, you notice you can't use the AC method, so you have to do the quadratic formula. And then if you can do the AC method, you do. And so what I would do is rearrange my terms so that I can get everything on one side. I want to keep my leading coefficient positive, so I wouldn't move my x squared, right? I move everything else to it. So I would get x squared. That would end up being a negative 2x. And then what we would have is a negative 3 equals 0. And then here, y'all, because that leading coefficient is 1 and a times c is 3, like a negative 3, you should be able to just do trial and error here. If you went it to the side and did the AC method, that's okay. But you should see here that x times x will give you x squared. Right here, these two terms should multiply to give you c, which is 3. And these two terms should also combine to give you a negative 2. Well, 1 times 3 are the only factors of 3. And if I combine them with a positive 1 and a negative 3, don't I get to a negative 2? Or go to the side, quickly do AC method. You can even do quadratic formula, right? Because that'll always work as well. Now I've got factors set equal to 0. You do the 0 factor property, which means you set each factor equal to 0 and you solve. So I would get that x equals negative 1 or x equals 3. So what would my answer be? 3. Yeah, because I can't take the log of a negative number. That make sense? Yeah, real algebra-y. I mean, obviously we're in algebra, but it's definitely going to use a lot of the stuff that you've already learned. Okay. Um, this is technically the same type of problem. I'll do another one just so that y'all have 3 for this method too. There's literally just one little quiz problem, so I think you'll be okay. It's only 31 right now anyways. Okay, let's do this third problem. So I'm saying I wanted you to see this so you can solve it on your homework. There's also kind of like a word problem. When I read it, it was pretty self-explanatory what it wanted you to do, right? If you want you to change forms, you should know how. And I think there may have been like one little bitty table which just wants specific parts. And I also think it should be okay. But if y'all don't get it and you need my help, like just tell me, okay? I could do like an exact example. So let's do this. Natural log of x minus 8 plus natural log x plus 1 equals natural log x minus 24. This is very similar to what we just did. In a way, I get that it's going to be a product rule, not a quotient rule, but I just want you to see why there's going to be a problem that says there's no solution. When you're like, hey, clearly I can get an answer. Like, I don't want you to be confused. The fact that I have multiple logs on the left-hand side and they're being added, this means that they can actually be written as what type of problem? Multiplication problem. Natural log. In parentheses, y'all, you have binomials, right? So you don't want to just write this binomial and this binomial with a dot in the middle, because that almost looks like only these 2 terms are multiplying. Keep the parentheses so you see that what it is FOIL, okay? Right-hand side, natural log, open x and a negative 24. Now I've gotten it to look like whatever kind of log you have, right? I've got a log and m equal a log and m. Because these are the same log, all I have to do is write m equals n. So I have x and a negative 8, close, open, x and a positive 1 equals, y'all, the only thing written on the right-hand side is x minus 24. You don't need parentheses there. If you wrote them, it wouldn't matter, but you don't need them at all. Because then you probably would accidentally confuse things you might move around as multiplication, okay? So here I have FOIL, right? First, outer, inner, last. You do the multiplication of the first 2 terms and you get a negative, I'm sorry, why did I say that? You get x squared. And then the multiplication of your outer terms, you get a plus x. Inner terms, negative 8x. Last terms, negative 8 equals x minus 24. On the left-hand side, I noticed like terms, right? Those terms that only have an x as your variable with 1 as the exponent, so those can be combined. I get x squared. Signs are different, so you would subtract, and you would keep the sign of the larger, keep your variable, keep your exponent. Minus 8 equals x and a minus 24. I'm doing like every single step. I don't even have this written here. Okay, and so now what we would do is we would move what we need to, right? I noticed that I've got an x squared. I'm going to do some kind of basically, I'm going to do some kind of factoring, right? So that means I need to get everything together. I'm going to move my x over, move my negative 24 over. What I would get is x squared. Signs would be the same. So you would add, keep the sign, you get a negative 8x. And then negative 24 becomes a positive 24. That's multiples of 8. So I would get positive 16 equals 0. And then now I would factor this, okay? If you took intermediate algebra or you're taking intermediate algebra, hopefully this has gotten a little bit easier for you. You'll notice here that what we actually have is a perfect square trinomial, right? And what that means is that it can be written as, that would be a negative 4 and a negative 4. You'll see in the homework what they do, because those factors are exactly the same, is you may see them write it as x minus 4 squared, because these are the same things. This is the condensed version. This is the expanded version, right? But doing this is fine. What I would do now, because I have factors set equal to 0, I always sound like a broken record, yeah. Set each factor equal to 0 and solve. They're the exact same factor, so I only need to do it once. If you did it twice, it's okay. You would get x equals 4 or x equals 4, right? They're the exact they're the exact same value. So you'll think, okay, x equals 4, and then they'll literally trick you, and they'll say, hey, x can equal 4, because even though x equals 4, I'm fixing to write my problem right here, y'all. If you actually plug in -4 where you have, not -4, a 4, sorry, where you have your x, you'll notice signs are different. We would subtract, keep the sign of the larger. I get natural log of a negative number, right? This one, that would be natural log of a positive number. Signs are different. Subtract, keep the sign of the larger. Regardless, the one time plugging my value in, if it gives me a negative number and I'm trying to take the natural log of a negative number or the log of a negative, if I can't talk, negative number, that will automatically mean that that value is rejected, right? Whenever we had x equals -1, I immediately rejected it, right? So they may even tell you to plug 3 in. I'll plug 3 in over here. Log of 5, natural log of 15. Those are positive, right? So those would end up working. You could use x equals 3 as your value. Here, if you plug in the value you found, it makes that negative. I didn't actually do it, y'all, but signs are different. So you would subtract, keep the sign of the larger. It's a -4. Plus natural log of, signs are the same. So you just get a 5. Equal, signs are different. So you would subtract, keep the sign of larger. Do you see how putting that value I found is trying to make me take the natural log of a negative number? I can't take the natural log of a negative number. Therefore, my x equals 4 is rejected. What you would say is that there's no solution. And this is the only time, y'all, that you should ever write this symbol. This does not mean 0. This does not mean undefined. This means no solution.
So should we always plug in what we get and see if it works or not?
Yeah, you can. Especially, I noticed in the homework it wasn't until the very end that it even had you do it and it told you no solution. All the other ones, there were solutions, but it'd be good practice to do it so that when you get to here, like you just automatically go ahead and do it. How do I know what? That it'll what? Me personally, when I saw that I plugged in 4 here and I got the natural log of -4, that meant that I couldn't actually plug in 4. And if 4 is the only value I have, then I don't have a solution. I don't think you'd have to do it to every single one. Because no matter, even if it's one natural log, having a negative number, or if it's all of them, that one keeps it from being able to even be computable or like solvable. Okay, y'all.